Welcome. Out of a group of 110 hikers, 17 of the 60 male hikers prefer hiking on mountain peaks. Out of the 50 female hikers, 21 prefer hiking in the woods. Finally, of the 41 hikers who enjoy hikes along streams, 16 of them were female. So part A, let's use this information to create a contingency table, and then we're going to find the requested probabilities here below. Okay, so for part A, the contingency table, well, hikers here are identified as either being male or female. So I'll start with those as my two rows. Now I'm going to need 3 columns, as we're told that some hikers prefer hiking on mountain peaks, some in the woods, and some along streams. Okay, so here's the setup for my contingency table. Here along each column is a hiking location preference, and each row is whether the hiker identified as male or female. So let's start. So out of a group of 110 hikers, so I'm going to put that right here. I know there was 110 hikers total. 17 of the 60 male hikers preferred hiking on mountain peaks. So I know that there are 60 male hikers and 17 of those preferred hiking on mountain peaks. Next, out of the 50 female hikers, 21 preferred hiking in the woods. So there's 50 female hikers and 21 prefer hiking in the woods. And then we're told of the 41 hikers who enjoy hiking along streams, 16 of them were female. So I know there's 41 hikers who enjoy walking along streams, and of those, 16 were female. That's all the information you're given, and now we need to work out what the rest of these cells contain. So this one's blank, all of these blanks we need to fill in. So go ahead and pull out a calculator, and once you have your calculator, notice we know the total for this row. There are 50 female hikers, so I know that this cell plus this has to equal 50. So we can subtract 21 plus 16 from 50, and that gives us 13. Well, that's really helpful now because I know here 13 plus 17 gives me 30. So I know there's a total of 30 hikers who prefer the mountains. I know that 13 female hikers prefer the mountains. So what about here, male hikers who prefer the woods? It doesn't look like I have quite enough information for this one yet because I have 2 blanks here. So let's look for something where we only have 1 blank. You can either go here or here. So this one here seems fairly easy. Let's do 41 minus 16, and that gives us 25. Now let's fill in this bottom row. So I know that 30 plus this blank plus 41 equals 110. So I can do 110 minus 30 and minus 41 to get 39. Now I can fill in this last blank here. I know that 21 plus whatever's in this blank has to equal 39. So this blank has to contain the number 18. So there is our completed contingency table. So now let's use this to find the probability that a hiker is male, and we call that event M. So the probability of M is equal to, well, there are 60 total male hikers out of 110 total hikers. That reduces to 6 over 11, which is 0.5455. Next, we have event W here in part C, which is a hiker prefers the woods, and the probability of W. The hiker prefers the woods. We have a total of 39 out of 110 hikers who prefer the woods. And this works out to be 0.3545. Next, what's the probability that a hiker is both male and prefers the woods? So let's look at their intersection. So here are male hikers And here are hikers who prefer the woods. So their intersection is here at 18. So the probability that a hiker is male and prefers the woods is 18 out of 110, which reduces to 9 out of 55, and works out to be 0.1636. Next, let's multiply the probability that a hiker is male by the probability that a hiker prefers the woods. Well, that gives us 6 over 11 times 39 divided by 110. I used the most reduced fractions for each. And that's 0, followed by a decimal, and then 1934. So part F. So in part F, we get the question, are being male and preferring to hike in the woods independent? Explain why. Well, first I want you to recall from a previous module that if any of these are true, then events are independent. Okay, so if one of these is true, we know our events are independent. Well, let's take a look really quick at our parts D and E. So if the probability of A and B are equal to the product of the probabilities, we know that these events are independent. But if you notice, the probability of M and W, so someone is male and hikes in the woods, is equal to this value, which is not equal to this value. So they are not independent. Okay, so since the probability of M and W does not equal the product of the probability of M with the probability of W, it follows that these events, namely being male and preferring to hike in the woods, are not independent events. I hope you found this video helpful.